Hello, my dear students. Hope all of you are fine. All of your exams are completed. All of you are taking rest now. I decided to make some more videos on deleted topics and like a bridge course. What all you have to prepare before you go to 11th and 12th. So, hope all of you will listen to it, attend to it, and definitely it will help to you for your further classes. Right now, today I wanted to tell you about logarithms, one of the very important topics called as a logarithm. All are there in CBSE. This is a new topic to you. It is not there till now. So first time you are going to know what are logarithms. Hope all of you have idea about exponents, correct? You have idea about exponents and how a number will be expressed in exponential form. I will tell you some examples. For example, we know 2 power 4 is 16. We know this. And some 10 power 2 is 100. Correct? 5 power x is equal to, for example, 625. I am asking you what is the value of x. All these are exponential related problems. If 5 to the power of x is equal to 625, we know 625 can be written as 5 to the power of 4 because bases are equal. You say that x is equal to 4. Correct? So here, for example, I have one problem here. Uh, 0.1. 1 minute. Yes, 10 to the power of 0 is 1. 10 to the power of 1 is 10. These all are what exponential forms. I have somewhere 10 to the power of something is equal to 0.1. I am asking you what is the value of x. Here also you will express 0.1 as 1 by 10, which is nothing but 10 to the power of minus 1. Therefore, x is equal to minus 1. Here also we got the value of x. 1 second, I will come back to you. Right. So this is what exponential forms. All these are exponential forms, and how do we find exponent value here? That is the concept. For example, somewhere I have 2 to the power of x is equal to 7. Can we find easily? We know 2 to the power of x is equal to some 8. We know easily x is equal to 3 because 8 can be expressed as 2 power 3. I'll repeat again. Let us see some more examples. For example, you have somewhere 2 to the power of x is equal to 8. Then easily you say that it is 2 to the power of 3, therefore x is equal to 3. But if my question is 2 to the power of x is equal to 7, can we find out what is the value of x here? By using exponents, it is difficult. We cannot. So to find out in this case also there exists some value of x. There exists some value of x such that 2 to the power of x is equal to 7. What is that? To find out exponent of 2 such that it is 7, we have another concept called as logarithms. Why we use logarithms? It is a exponent of a base to raise to get another number like 2 to the power of x is equal to 7. What power must be raised to 2 so that we get 7. For example, how we write the definition? We have a to the power of x is equal to n. This is exponential form of n. A to the power of x is equal to n. What it means? What power of base should be raised? What power of base should be raised so that we get result n? To find out x in this case, we use logarithmic concept. This same exponential form, a to the power of x is equal to n, can be written as log n to the base a is equal to x. So, x should be raised log n to the base a times to get a to the power of x. So, it is what? If a to the power of x is equal to n, then what it means? Log n to the base a is equal to x. So, simply now onwards you remember, if you have anywhere a to the power of x is equal to n, then this is exponential form of a number. The same exponential form of a number can be expressed as log n to the base a is equal to x. So this exponent will become a result here. Okay, here result will become here n, same. But a is base a as it is. So if somewhere exponential form is there like this, we can express it in the form of logarithmic form like this. I will tell you some examples. For example, I have 2 to the power of x is equal to 16, I said. Then what we can write it in the logarithmic form? It can be expressed as log 16 to the base 2 is equal to x. Log 16 to the base 2 is equal to x. Now we know here 2 to the power of x is equal to 2 to the power of 4. So x is equal to 4. So what it is? Log 16 to the base 2 is equal to 4. Okay. Or I will tell you another easy way. We know 2 to the power of 4 is equal to 16. 2 to the power of 4 is equal to 16 is exponential form. Now same thing can be expressed in logarithmic form as log 16 to the base 2 is equal to 4. Okay, now let us see some examples in exponential form and then logarithmic form to understand better. 10 to the power of 2 is equal to 100. 10 to the power of 2 is equal to 100 is logarithmic form. Then what is exponential form here? Log 100 to the base 10 is equal to 2. That is what? Logarithmic form. Let us see one more example. We know 5 to the power of 2 is equal to 25 is exponential form. Write in logarithmic form what it is? Log 25 to the base 5 is equal to 2. So 5 should be raised 2 times to get 25. Similarly, one more example, 3 to the power of 4 is equal to 81. What is the logarithmic form? So 3 should be raised. How many times 3 should be raised? Log 81 to the base 3 is equal to 4. So how many times 3 should be raised? 3 should be raised 4 times to get 81. Okay, so this is what? Exponential form and it is logarithmic form. Hope you understood the basic representation of a logarithm. It is the another representation, like exponents is one type of representation, logarithmic form is another type of representation, exponents and logarithms. Now let us see what are the important laws or important formulas we have based on logarithms. These are some very important formulas you have to remember in logarithms. In that first one, better you note down, copy, so it will be useful later. Log xy to the base a. If you have product of two numbers, then we can write it as log x to the base a plus log y to the base a. We call it as sum law of logarithms. Next one, product law. That is what? Product law, product of two numbers. Okay, product law of logarithms. Second one, log of x by y to the base a is equal to log x to the base a minus log y to the base c. This is what quotient law of logarithms, product law, quotient rule. One more, third, these three are very important. Log x to the power of m to the base a is equal to m into log x to the base a. So according to the first law, whenever you have product of two numbers, we can express it as sum of two logarithms. Second one, if it is like quotient, we can write it as difference of two logarithms. Now it is power, we also call it as power law. If power is there like this power will be multiplied here front. This is called power law. So these all are what? Important laws of logarithms. Not only this, we have few more. If you have power in the numerator upper, that x, it will be multiplied like this. Suppose if you have like this log x to the base a to the power of n, log x to the base a to the power of n, then we can write it as 1 by n log x to the base c. So it will be multiplied. 1 by n will be multiplied if power is there to the base a. One more we can write like this. Suppose you have power for both the numbers. Log x to the power of m base a to the power of n. Then we can write it as m by n log x to the base a. That m will be numerator and this n will be denominator. So these are some laws, and other than this, apart from this, we have some other laws of logarithms also. Somewhere if you have like this log x to the base a, we can also write it as 1 by log a to the base x. It will be like x will go to a place and a will come to x place. Log x to the base a can be written as 1 by log a to the base x. All these you have to remember. This will be useful in solving problems. We will discuss some problems also today. And this is what next one. If log x to the base a is there, 1 by log a to the base x we can write. And one more. Suppose if you have like this log x to the base b into log b to the base c into log c to the base a is equal to, see here, these two are same. Again, these two are same. So when you have like the same, this one can be written as log x to the base a result. Hope you understood up to here. So this is one more law. So what you have to remember here? These base and this up number. These two numbers are same. This number and last number you have to take it in result. So that is what one more law. Then here one more, a to the power of log x to the base a. If it is somewhere like this, result is x. Better you note down all this. Ninth one, log a to the base a. When these two are same, result is 1. If these two values are same, result is 1. Similarly, last one, log 1 to the base a is 0. Log 1 to any base is 0. These two also you have to remember. So try to note down these rules. If these are done, we will discuss some problems related to power law today. This rule, problems related to this rule, some simple basic problems related to this rule we will discuss today. Let us see what are the problems we have. First one, these are some problems related to logarithms. First one we have, see here like this we have, now it is looking like log x to the power of m to the base a. I told what is log x to the power of m to the base a. log, it is looking like log x to the power of m to the base a, which can be written as m log x to the base a. So according to that, this power should be multiplied in front. So it will become 20 log 7 to the base 7. 20 log 7 to the base 7. Now again I said one more formula also here. What is that? Log a to the base a is equal to 1. In this total, in all these problems, which two laws we use? First one, log x to the power of m to the base a is equal to m log x to the base a, one formula, and one more we use log a to the base a is equal to 1. These two formulas we use here. According to first formula, it is 20 log 7 to the base 7, and I told this is looking like log a to the base a. So that result is 1. So we can write it as 20 into 1, whose result is 20. Hope you understood this first one. The second, once we check the second, it is not in exponential form, but we can write 81 as 9 to the power of 2. Base is 9. So up also we have to get 9. So we can write it as log 9 to the power of 2 to the base 9. Now it is looking like this first one. So according to power rule, what we write, this power will be multiplied here. So we can write it as 2 log 9 to the base 9. Now again log 9 to the base 9 is 1. So we can write it as 2 into 1. 2 into 1 is 2. Hope you understood this result also. Now the next one, you can see here, this is 6 to the power of 1, but this is 36. 36, how can we write in terms of 6? We can write it as log 6 to the power of 1 to the base 6 to the power of 2. Why? Because 36 can be written as 6 to the power of 2. Now, you know, we learned one more formula, that is log x to the power of m to the base a to the power of n. When powers are there like this, we write m by n log x to the base a. This formula we use here. Okay, m and n, both powers are there, then we write m by n. By using this formula, what we can write it? 1 by 6 log 6 to the base 6. 1 by 6 log 6 to the base 6. Again, log 6 to the base 6 is what? 1. Oh, it is not 1 by 6, it is 1 by 2. Because base is having power 2. 1 by 2 log 6 to the base 6. So it is what? 1 by 2 into 1, which is further it is only 1 by 2. Hope you understood this also. Now coming to the next. Now that this one, we can write it as log 27 should be expressed in terms of 3. How can we write? 1 by 3 power 3 to the base 3. You know what is 1 by 3 power 3? We can write 3 power minus 3. 1 by 3 power 3 can be expressed as log 3 power minus 3 to the base 3. Now we can use power rule here. This can be written as minus 3 log 3 to the base 3. Now this value is 1. So what it is? Minus 3 into 1, which is minus 3. Hope you understood this. Next, this one, log 0.2 to the base 5. How to express 0.2 in terms of 5? Will you try 0.2? How can we write in decimal form? 0.2 in p by q form. 0.2 in p by q form is what? 0.2 in p by q form is 2 by 5, 2 by 10. Again, 2 by 10 can be written as 1 by 5. What is 1 by 5? 5 to the power of minus. So first we have to simplify what is 0.2. So what? 0.2 can be written as log 5 to the power of minus 1, because 0.2 value we got 5 to the power of minus 1. So log 5 to the power of minus 1 to the base 5, which can be written as minus 1 into log 5 to the base 5. What is log 5 to the base 5? Minus 1 into 1, which is minus 1. Hope you got this one also understood. So first you should express 0.2 in terms of 5. Both up number and down both should be expressed in terms of same. So here next 100 to the base 1000, you have to try it. Next value, we can try it. 100 and 1000, how can we express in terms of same number? We know 100 is 10 to the power of 2, 1000 is 10 to the power of 3, 100 is 10 to the power of 2, 1000 is 10 to the power of 3. So we can write this as log 10 to the power of 2 to the base 10 to the power of 3. Now again it is looking like log a to the power of m to the base log x to the power of m to the base a to the power of m. Both powers are same. So 2 will come into the numerator, 3 will come into the denominator. So it will become 2 by 3 log 10 to the base 10. Now we all know log 10 to the base 10 is 1. So it is what? 2 by 3 into 1, whose result is 2 by 3. Hope you understood that also. All these are some simple problems. Then later tomorrow we'll discuss some more complicated problems. Now 0.25 and down 8 we have. Both should be expressed in terms of same power. So let us simplify 0.25 first. 0.25, how can we write? 0.25 can be written as 25 by 100. Correct? So 25 by 100 of cancellation, what it is? 1 by 4. And 1 by 4 is 1 by 2 power 2, which is 2 power minus 2. Hope you understood how can we express 0.25 in terms of 2. Okay, so 0.25 is what? 2 power minus 2. So, and 8 we know it is 2 power 3. So, I am writing it as log. Okay, let us write here again 25 by 100 to the base 2 power 3, because 8 is 2 power 3. Now, after cancellation, it is 1 by 4. So, we can write it as log 1 by 4 to the base 2 power 3. So, that is what 1 by 4 is 2 power minus 2. So, we can write it as 2 power minus 2, 2 power minus 2 to the base 3, 2 power 3, 2 power minus 2 to the base 2 power 3. So, again, minus 2 will come into the numerator, 3 will come in the denominator, minus 2 by 3, log 2 to the base 2. Log 2 to the base 2 is what? 1. So, what is the result? Result is minus 2 by 3. Hope you understood that. Result is minus 2 by 3. Next one here, we have 0.04. We have to express it in P by Q form like before. So, it is 4 by 100. What it is? Log 4 by 100 to the base 5. Now we can cancel 4 and 100. 4 ones are 4, 25s are. So what it is? Log 1 by 25 to the base 5. Now 25 is what? 5 to the power of 2, but it is 1 by 5 to the power of 2. We can write it as log 5 to the power of minus 2 to the base 5. Means what? To the base 5 to the power of 1. 5 to the power of minus 2 to the base 5 to the power of 1, which is power will come into front. So minus 2 log 5 to the base 5. We know log 5 to the base 5 is 1. So it is what? Minus 2 into 1, which is minus 2. Result is minus 2. Hope you understood up to here. Everywhere used power formula, that up number and down number both you have to express in same number. Now this one, if you see, it is looking like another formula. I told you one formula, log a to the power of log x to the base a is equal to x. If these two numbers are same, a to the power of log x to the base a, if these two numbers are same, then the result is x itself. So here also, what is the answer we can write? This answer is because these two are same. What is the result? 27 by that formula directly you can write. But this is different again. It is not 3 to the power of log 27 to the base 3. This is different. And 10th problem is different. 10th problem, what you have to do? This part we have to simplify first. First we have to simplify log 27 to the base 3. What is log 27 to the base 3? Log 3 power 3 to the base 3. Because 27 is 3 to the power of 3. Now we can write it as, this 3 will be multiplied here. 3 log 3 to the base 3. That is 3 into 1. Answer is 3. So this total result we got 3. So what we can do in this place, we can write 3 log of log 27 to the base 3. This result is just 3. So we can write it as log of 3 to the base 3 because this total result is 3. Now what is log 3 to the base 3? 1. So this result is 1. Hope you all understood all these problems. You can express whether is it okay or not. Clear? Did you understand all this? It will help you definitely when you go to your next levels. I am trying to give at least what is logarithms idea. We'll discuss some more problems. In tomorrow's class, we'll discuss more, but here I want to tell you one more worksheet. So very simple only. These are also very simple. Tomorrow onwards, we'll go some more deep. So here in all these, what you have to do, we have to find the value of x. Everywhere we have to find the value of x. Now see here, how can we find? I told you one concept. What if a to the power of x is equal to n? Then I said log n to the base a is equal to x. This is called exponential form. This is called logarithmic form. We can convert both. We can convert a number from exponents to logarithms or logarithms to exponents. Here it is there in logarithmic form. If you convert that into exponential form, we get very easily. So when you wanted to convert any logarithmic form into exponential form, this 5 we have to write here. So what will become? 5 to the power of 4 is equal to x. Okay, logarithmic form to, I tell you here, if you have somewhere log n to the base a is equal to x. How can we convert this into exponential form? This a we send here so that we get a to the power of x is equal to n. Okay, and similarly, if a to the power of x is equal to n, when we convert this into logarithms, this n will go up. Log n to the base a is equal to x. So both you have to know. If a number is there in exponential form, you should know how to write it in logarithmic form. At the same time, if it is in logarithmic form, you should know how to write it in exponential form. So I wrote, the given question is there in logarithmic form. So to get it easily, what is the answer? I am writing it in exponential form. So this 5 if you send there, what we get? 5 to the power of 4 is equal to x. So what is 5 to the power of 4? 5 to the power of 4 is 625. So what is x now? 625 is x. Therefore x is equal to 625. I will tell you in another way. Just now we have done some problems like this. For example, there if 625 is there, log 625 to the base 5. What is the result? In the previous process, 625 can be written as 5 to the power of 4 to the base 5. This 4 will come front. 4 into log 5 to the base 5, that is 4 into 1, which is 4. See, if 625 is there in the place of x, we get result 4. So this is one way, and this is another way. If it is given like this, how can we find? Just send this 5 that side. 5 to the power of 4 is equal to x. Therefore, x is equal to 625. Hope you understood the solution. Similarly, here, we want x here. Here, how can we do it? We can follow in any method. One method is again, you send this here. We get 10 to the power of x is equal to 0.1. What is 0.1? 1 by 10. Again, what is 1 by 10? 10 to the power of minus 1. Therefore, what? If 10 to the power of x is equal to 10 to the power of minus 1, x is equal to minus 1. X is equal to minus 1. Same problem in another way, how can we do? Log 0.1 can be written as 0.1 by, log 0.1 can be written as 1 by 10. 1 by 10 to the base 10, which is log 10 to the power of minus 1 to the base 10. Minus 1 will come front, minus 1 into log 10 to the base 10, which is minus 1 into 1, that is minus 1 itself. This is another way of finding solution. This is by using exponents, this is by using logarithms. Hope both you understood how to find out x when question is given like this. Next question. Here, again same, like here. What? You have to change this into exponential form. We get x is equal to 4 to the power of 2. Therefore, what? X is equal to 16. Very simple. So here also same. How? If you change that into exponential form, x to the power of 3 is equal to 1000. What should be x so that we get 1000? 1000 is 10 to the power of 3. Therefore, what we got? X to the power of 3 is equal to 10 to the power of 3. Therefore, x is equal to 10. Hope you understood today's some simple basic logarithmic concepts. What are logarithms and what are logarithmic concepts? Do you want to know further some more? How is today's class? You can express. Is it good? We'll continue. Otherwise, tomorrow we'll discuss. If you want to listen more, I will continue. Otherwise, shall we discuss from tomorrow? How is it? Today's class? Okay. Let us see some more operations, because anyway you are here, some of you. I'll try to discuss few more. Suppose I have one question like this: log 15 to the base 10. This is a single logarithmic term. They ask you to write it in expanded form. Log 15 to the base 10 is in single logarithmic form. They may ask you to write it in expanded form. So what we can write it? Log 3 into 5 to the base 10. Log 3 into 5 to the base 10. I told you one formula: log x into y to the base 10 can be written as log x to the base 10 plus log y to the base 10. So according to this formula, how we can write it? Log 3 to the base 10 plus log 5 to the base 10. I told you one very simple problem. Now similarly, suppose we have one more question: log 60 to the base 10. They are asking you to write in expanded form. So what is the 60 factorization? 230, 2, 15, 3, 5. So how can we write it? We can write it as log 2 to the power of 2 into 2 to the power of 2 into 2 to the power of 2 into 3 to the power of 1 into 5 to the power of 1. Okay, it is not only xy. If you have z, what happens? One more will be added. How many numbers you multiplied here, those many terms will be added in the logarithm. So here three terms are there. So we can write it log 2 to the power of 2 to the base 10 plus log 3 to the base 10 plus log 5 to the base 10. Again, because it is exponential form, again power rule we can use. This power will come front. So we can write it as 2 log 2 to the base 10 plus log 3 to the base 10 plus log 5 to the base 10. These are what some problems where if it is in exponential, where it is in single logarithmic term, it is given in single logarithmic term, we are writing in expanded form. Like this, few more are there, complicated problems. We'll discuss in tomorrow's class exactly at 7:30. You inform your friends whoever are interested. This is just introduction. We'll discuss many more, like not only logarithms, trigonometry we have, functions we have, matrices we have, which you do not know in your 10th. Many topics are deleted. Even in coordinate geometry also, many other topics are there. So in this summer, before you going to 11th and 12th, I wanted to conduct at least 30 minutes to 40 minutes every day so that you can know those formulas and concepts. We can revise them. So when you go back to your 11th, 12th, because already all these will be there in your mind, we can understand very easily all of your topics. Hopeful, I hope all of you will utilize it. Share to your friends, let them join, try to know all these basic concepts. Thank you. Tomorrow we meet at same time here in our live session. Thank you.